Today I am presenting the concept of analysis of variance. In this one, we are understanding the different types of variations, and the second one, fixed and random effects, and different types of classifications of Anova. Okay. Now, coming to variations, generally there are two types of variations. One is assignable variations, and another one is chance variations. In assignable variations, the factors we are studying is under control, is identified and measured and removed. Coming to chance variations, we cannot identify, we cannot eliminate, and we cannot measure. So such a variations are called as random variations. So there are different types of assumptions we are adopting in analysis of variance. So these three basic assumptions we need to apply the analysis of variance. So the first one is observations are independent. What the sample we are taken, that population should follow normal distribution, and various treatment effects are relative in nature. In general, treatment effects may be multiplicative or mixed one. But here, when we have to apply analysis of variance, so the factors are additive. Okay. Now coming to classifications of different types of ANOVA. So there are different types. What the number of factors we are studying called number of classifications. So, for example, one-way classification means we are studying only one factor, and that is affected by one assignable factor. So, when we are taking a two-way classification, so there are we are taking only one factor, but there are two assignable factors are applying on one factor, and what the factor we are going to study called as a treatment. Now, coming to one-way classification. So, in general, the one-way classification will be like this: x11, x12, so on x1, n1, x21, x22, so on x2, n2. Now, in this one, the first suffix representing the first treatment. So, the different type of assignable factors we are going to study will be represented by the first suffix, and second suffix representing number of observations exposed to that treatment. Okay, x11, x12, so on x1n. That means the first treatment is exposed to n1 treatment, n1 values. Coming to second treatment, we are taking n2 observations. So on, for example, kth treatment, we are taking n suffix k observations. Okay, and these observations never be equal or maybe equal. Okay, so that means n1 equal to n2 equal to so on nk in some cases, but in general, in practice, in one-way classification, we are not considering it as a not equal. Okay, the mathematical model we are applying on one-way classification is xij equal to mu I plus epsilon ij. So here mu I means what the treatment we are applying is called as a mu I, and it is divided into two components. One is a general effect, and another one is a net treatment effect. Okay, so here mu I equal to mu I is the general mean effect, alpha I mu I minus mu. So that is called as a net treatment effect, and epsilon ij is the random effect. So that is these three effects are gives some result that is called as a xij. Now by using regression method or estimation method, we are estimating mu I, alpha I, and epsilon ij values, because those all these three values are parameters. So we have to convert into sample values. So for that one, we are using either regression technique or estimation method. So here we are using estimation method, that is also MLE method, maximum likelihood estimation method. So by using maximum likelihood estimation method, we are getting UI as a x bar double dot. So alpha I means x bar I dot minus x bar double dot plus xij minus x bar I dot, that is called error component. Okay. Now the hypothesis to be tested under Anova one-way classification is mu1 equal to mu2 equal to so on mu k equal to mu, or alpha 1 alpha 2 so on alpha k equal to 0. Alpha 1 equal to 0 means mu mu 1 minus mu equal to 0, that is mu 1 equal to mu. Okay. So in other sense we are writing like this, so the statistics we are using in one way classification is f. So because we are testing number of means. Suppose if you want to test only two means, we are using t statistic. Okay, but we are using here testing number of means, that is 1 to k. So that's why we are applying f statistic. And f statistic means mean sum of square due to treatments by mean sum of square due to errors. So mean sum of square means nothing f. Okay. Now the complete values are enumerated into a single table called one-way table. So this is a standard columns table: source of variation, degrees of freedom, sum of squares, mean sum of squares, and variance ratio. So we are using treatment, errors, and total. So this is a final concluding table of one-way classification. Now coming to two-way classification, let us consider two factors which may affect the variable. So here two factors means, so we are applying two type of treatments for getting some result. So that is called as we are called it as a factors. So the entire data will be divided into H classes, and each class containing k observations. And a general format of the two-way classified data is x11, x12 so on x1k, x21 so on x2k. So here the post suffix representing the post treatment, that is the post factor we are applying, and the second suffix representing second factor, that is the second treatment we are applying. Okay. So here we are taking equal number of observations. So that is the a major difference between one way classification and two-way classification. Now, coming to the mathematical model we are using here, mu ij plus epsilon ij. So, where in one-way classification we are using only mu I plus epsilon ij, but coming to two-way model, we are taking two suffixes mu ij. That means so I representing the first factor and j representing the second factor. Epsilon ij error term. So the total impact on the total impact, that is xij, will be equal to assignable effect and chance effect. Now, chance effect will be taken. We cannot break into different type of components. So now coming to assignable component, that is mu ij, that will be broken into three components. One is general effect, net net treatment effect of first factor, and net treatment effect of second factor, plus gamma ij. So here gamma ij means it is an interaction effect. Interaction effect. But before starting of two-way classification, we are putting one assumption. So that is called for each cell we are taking only one observation. That means we are not allowing two observations per cell. That means automatically interaction effects will become zero. That means mu ij will become zero. So Finally, the mathematical model will become mu plus alpha I plus beta j plus gamma, sorry, epsilon ij. Okay. Again, like in one-way classification, we are estimating these parameters. So mu, alpha, beta, and epsilon are all estimated through regression or method of estimation. Here we are using maximum likelihood estimation method for estimating those parameters. By applying MLE, we are getting mu as x bar double dot, alpha I as x bar I dot minus x bar double dot, plus beta j as x bar dot j minus x bar double dot. And finally, error component. Total effect minus first factor effect minus second factor effect plus overall mean. That is a balancing factor. So that will use a statistical model of the given mathematical model. Okay, now the hypothesis to be tested here is we have to test both the factors, factor 1 and factor 2. Okay, so for factor 1 we are using one type of one statistic, and for another factor 2 we are using another statistic. For example, first two factor, that is alpha 1, alpha 2, so on, alpha h. Okay, so sum of treatment mean sum of square due to treatments by mean sum of square due to errors. Similarly, mean sum of square due to blocks by mean sum of square due to errors. Okay, here the second factor we are calling it as some blocks. Then I am using a s square suffix b. If calculated values of f are less than the table values, then we accept the then we accept the corresponding hypothesis. And finally, the table the table we are adopting in a two-way table is yeah, like in one-way classification. That is a source of variation, or degrees of freedom, sum of squares, mean sum of squares, variation. All are common columns, but we are taking treatments, blocks, errors, and treatment. Here treatments means factor 1, blocks means factor 2, and error, and finally total. Okay, so the main application, what the terms we are discussed so far, that is Anova, one-way classification, two-way classification, all these are the a basic application component of the major topic called as a design of experiments. Okay, so design of experiments. In this one, the experiments are classified into three types. So one is absolute, another one is a comparative, third one is a random experiment. Suppose if a result is explained before completion of the experiment, then it is called as a absolute. On comparison, of two or three situations, the result will be explained. Then it is called as a comparative experiment. A random experiment means in which the result cannot be explained in any way. That is, in before completion of the project, on comparativeness of the project experiment. So such experiments are called as a random experiments. Now we are studying here random experiments. So in this one we are using some basic terminology. Okay, the first one is treatment. That is various terms, various factors we are considering for comparison, called as a treatment. Experimental unit. The entire experimental material so is divided into a small component called experimental units. Blocks. Blocks means a relatively homogeneous subgroups. The entire material will be divided into homogeneous. Okay. Now, the most powerful one, and it is here, is experimental error. That is the variation between experimental units. That is called as within the variations. Okay, so suppose you take a one block. So that block is divided into different units, experimental units. So the variation between one unit to another unit in a block is called as an experimental error. Okay, now here when going to applying design of experiments, we have to follow three basic principles. So the one is replication, another one is randomization, and the third one is local control. Okay, now coming to replication. Replication means we have to repeatedly apply the treatments called replication. Okay, that number will be decided by using a t statistic. Okay, so the here R is defined as a 2 into t square suffix alpha. That is a student's t value at alpha level of significance. Okay, S square means standard error. T is the deviations. Okay, so this is the formula we are using to measure replication number. Okay, so generally for number of replications, the following factors we are considering. So how much precision we have to adapt, how much precision we required, and another one is what fraction of sample we are considering, and the size of experimental units. Suppose if you are taking a small size of experimental units, we require a number of replications, because so that small unit may exhibit the proper result or not, and availability of resources, and number and nature of the treatments. Suppose certain treatments are very perishable and costly, then we are adopting a small number of replication, small number of replication. And the randomization means it is the allocation of treatments to experimental units on a random basis. And the third one is local control. So it is the reduction of experimental error. Okay, it is a device used to maintain the greater homogeneity between experimental units. That means greater homogeneity means we have to reduce the experimental errors. Then automatically it means local control. Okay, now there are three types of designs we are studying here. One is a completely randomized design, another one is a randomized block design, and third one is a Latin square design. These three are the basic randomized designs. Okay, so in the my next session, in the next class, I will explain all those three designs.